In this lesson, we're going to be talking about one of the simplest ways to estimate the protein concentration in your sample: direct measurement of the absorption in the ultraviolet spectrum of light. This method takes advantage of the fact that aromatic amino acids have a peak of absorbance at 280 nanometers. So all we have to do is place our sample in a cuvette, put it in the spectrophotometer, read the absorbance at 280 nanometers, and then interpolate the data based on a standard curve. To run your UV absorbance assay, in addition to having your test samples, your blanks, and your standard curve, you're also going to need to have either a spectrophotometer or a plate reader, together with the appropriate quartz cuvettes or microplates. If you choose to run your assays using cuvettes, you're going to need 1 milliliter of sample per cuvette, whereas if you run it on a plate, you're going to need 0.25 milliliter of sample per well. Remember to always take into account that you should prepare 3 technical replicates of each sample. This assay is not compatible with samples that have a low content of tryptophan and tyrosine, because those amino acids are the ones that have a high absorption peak at 280 nanometers. This assay is also not compatible with samples that contain detergents such as tritone X, because they usually have a high absorption peak in the UV range. This assay is neither accurate or sensitive, and it has a wide dynamic range of 20 to 3000 micrograms per milliliter. It's very high throughput and extremely cheap. If you'd also like to address sample purity, in addition to measuring absorbance at 280 nanometers, you can also measure it at 260 nanometers. Reason for that is that proteins have an absorbance peak at 280 nanometers, while nucleic acids have an absorbance peak at 260 nanometers. So if we calculate the ratio between the two absorptions, 280 divided by 260, that will let us know if there is any nucleic acid contamination. You may even decide to take advantage of the Warburg-Christian method, which allows you to estimate how much nucleic acid is present in your sample. Using that method, if you get a value close to 1.75, that means your sample is extremely pure. If your buffer composition or sample type don't allow you to use the 280 nanometer wavelength, you may choose to shift that to 205 nanometer wavelength, which is the peak of absorbance of peptide bonds. Please don't forget to watch our best practices video on this course, since it has very important content on standard curve and data analysis that will help you through this process.